Hello students, very good morning. Now today we will discuss Coulombs law or Coulombs law of electrostatics. What is actually Coulombs law of electrostatics? As in earlier classes we discussed that if there are two stationary charges, they will exert some force on each other, either attractive or repulsive. That depends on their nature. If the charges are of same nature, they will repel each other. If the charges are of different nature, they will attract each other. So it is for sure that there will be some force between the charges. Now on what factor that force depends, it is given by Coulomb's law of electrostatics. Now what is Coulomb's law? Let us discuss. In class 11th you might have studied gravitational law, that was F is equals to G m1 m2 upon r square. This was gravitational law, Newton's gravitational law. You may have studied in class 11. Comparing with this, Coulomb's law is quite similar to this. Coulomb's law जो है लगभग इसी की तरह है, इसलिए ज्यादा दिक्कत नहीं होगा समझने में आप लोग को. है क्या Coulomb's law? इसको समझने के लिए हमको थोड़ा सा ये समझना पड़ेगा. Let us consider there are two charges in a space, two stationary point charges. Okay, two stationary point charges which are placed in space q1 and then another charge is q2. These both charges are placed in some space at a distance r from each other. Now they will either attract each other or they will repel each other depending on their nature. But with what force they will attract or they will repel each other, this is given by Coulomb's law. And Coulomb's law is what? It states that the force of attraction or the repulsion between the two charges is directly proportional to the product of magnitude of two charges, that is q1 into q2. सो पहला स्टेटमेंट क्या है? दोनों के बीच में लगने वाला जो फोर्स होगा वो डायरेक्टली प्रोपोर्शनल होगा दोनों के चार्जेस के मैग्नीट्यूड के प्रोडक्ट के प्रोपोर्शनल होगा. डायरेक्टली प्रोपोर्शनल मींस इफ द चार्जेस आर ऑफ बिग मैग्नीट्यूड द फोर्स विल आल्सो बी लार्ज. अगर चार्ज बड़े हैं तो फोर्स भी ज्यादा होगा, चार्ज छोटे हैं तो फोर्स भी इनके बीच कम लगेगा. ओके, एंड द सेकेंड स्टेटमेंट ऑफ कूलम्स लॉ इज इनवर्सली प्रोपोर्शनल. देखो यहाँ पे it was directly proportional to product of masses, inversely proportional to square of distance between the two masses. In same way, वैसे ही एकदम सेम तरीके से it is directly proportional to product of two charges and inversely proportional to square of distance between the charges. This is Coulomb's law. This is Coulomb's law. अब आप समझ गए होंगे Coulomb's law को. So statement लिखते हैं, it states that the force of attraction or repulsion between two stationary point charges is directly first is what? Directly proportional to product of their magnitude of charges. Directly proportional to the product of their magnitude, and second inversely proportional to square of distance between them, and inversely proportional to square of distance between them. Okay, so this is very favorite topic of boards and also from the point of competitive level it is an important topic. इसमें आप देखेंगे तो जो इनवर्सली प्रोपोर्शनल है डिस्टेंस के, अगर डिस्टेंस वी आर इंक्रीजिंग द डिस्टेंस 2 टाइम्स देन फोर्स विल डिक्रीज बाय अ फैक्टर ऑफ 4 टाइम्स. दो गुना अगर डिस्टेंस बढ़ेगा तो 2 का स्क्वायर 4 टाइम्स फोर्स डिक्रीज करेगा. अगर 3 टाइम्स डिस्टेंस बढ़ेगा तो 3 का स्क्वायर 9 टाइम्स फोर्स डिक्रीज करेगा. तो ये जो क्वेश्चन ऑप्शनल में आते हैं इट इज ऑफ दिस टाइप कि if the distance between the two charges are increased by twice what will be the effect on the force. इस तरीके से आते हैं. या it is reduced by half of the original distance what will be the effect on the force. इस तरीके से ऑप्शनल क्वेश्चन बनेंगे. So try to understand the concepts. क्वेश्चन तो आप अपने आप कर लेंगे after understanding the concepts. So ये हो गया. Now combining both the equations, इन दोनों equations को हम combine कर देते हैं. Combining equation first and second, force is proportional to q1 q2 upon r square. force क्या हो जा रहा है? proportional to q1 q2 upon r square. Okay, now to remove this proportionality we have to multiply a constant, या फिर in other words we can say that the ratio of this will be a constant. मैथमेटिकली यही होता है कि f upon q1 by q2 upon r square equals to कांस्टेंट. तो अगर कांस्टेंट प्रोपोर्शनैलिटी को हटाना है कांस्टेंट को मल्टीप्लाई करते हैं सो दिस फोर्स विल बिकम F इक्वल्स टू K इंटू Q1 Q2 अपॉन R स्क्वायर. ठीक है, सो दिस इज कूलम्स लॉ. नाउ व्हाट इज दिस K? ये कांस्टेंट क्या है? लेट अस डिस्कस ऑन दिस. सो दिस K इज इक्वल्स टू 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught. It is a constant. It is a medium constant, not a universal constant. ये universal constant नहीं, it is a medium constant. Means its value will vary with the change in medium. Medium change होगा तो इसका value confirm change होगा. ये बात एकदम ध्यान में रखना. Okay? And this is a constant for air, vacuum or free space. और फ्री स्पेस. मतलब ये वाला कांस्टेंट हम तब यूज करेंगे व्हेन आवर चार्जेस आर प्लेस्ड इन वैक्यूम और इन एयर ऑन इन फ्री स्पेस. अलग अलग राइटर अलग अलग वर्ड यूज करते हैं, कोई एयर, कोई वैक्यूम, कोई फ्री स्पेस. सो ऑल हैज सेम medium constant, that is 1 by 4 pi epsilon naught, and its numerical value is 1 by 4 pi epsilon naught. Its numerical value is 9 into 10 power 9 Newton meter square per Coulomb square. It is the numerical value of 1 by 4 pi epsilon naught. So in air or vacuum, the force between two charges equals to 1 by 4 pi epsilon naught q1 q2 by r square. Force का unit क्या होगा भाई लोग? Newton. The unit of force will be Newton. Okay. From class 11th you know this. The unit of force is Newton. So here the force unit will be Newton. So according to Coulomb's law, the force between two charges placed in any medium is directly proportional to product of their magnitude and inversely proportional to square of distance between them. Okay. So pause the video, make a note in your fair copy. Okay. ये सारा चीज नोट में होना चाहिए. वीडियो को पॉज करके स्क्रीनशॉट लेके Coulomb's law हेडिंग लगा के after putting the heading Coulomb's law, make a note of all these topics. Okay, now come back. Next topic is Coulomb's law in vector form. Coulomb's law is what? F is equals to 1 by 4 pi epsilon naught q1 q2 by r square, where 1 by 4 pi epsilon naught is a medium constant and its numerical value is 9 into 10 power 9 Newton meter square per Coulomb square, and it is for air, vacuum और फ्री स्पेस। इट मींस अगर चार्ज एयर, वैक्यूम या फ्री स्पेस में होगा तो उनके बीच का जो मीडियम कांस्टेंट होगा वो होगा 9 इंटू 10⁹। अगर मीडियम चेंज हुआ, फॉर एग्जांपल इफ द चार्जेस आर केप्ट इन वाटर, this value will change. If the charges are kept in some dielectric medium, this value will change. So this is not a universal constant. This is a medium constant. Be careful, okay? Its value will change with the change in medium. Next, Coulombs law in vector form. So again, let us consider two charges, Q1 and Q2, placed in a space at a distance r from each other. These two charges are placed at a distance r from each other. Okay. So now what will happen? Q1 पे एक फोर्स लगेगा ड्यू टू Q2 और Q2 पे एक फोर्स लगेगा ड्यू टू Q1. अब what will be the nature of force? That will depend on the nature of charge, either attractive or repulsive. तो हम मान लेते हैं दोनों चार्ज, बोथ द चार्जेस आर ऑफ सेम नेचर, तो दे विल रिपेल ईच अदर. तो Q1 को Q2 इधर रिपेल करेगा, फोर्स ऑन वन ड्यू टू सेकेंड. दिस विल बी द डायरेक्शन ऑफ फोर्स. Vector Coulombs law in vector form. Actually in Coulombs law we had calculated the magnitude of force, but we had not calculated the direction of force. Therefore vector form of Coulombs law is very important. We have to analyze Coulombs law in vector form also, means we have to find out the direction also. So on charge Q1 एक फोर्स लगाएगा Q2 जो कि इस डायरेक्शन में जाएगा, और Q2 पे एक फोर्स लगेगा Q1 की वजह से, F ऑन सेकेंड ड्यू टू फर्स्ट. न्यूटन जी का थर्ड वाला नियम, थर्ड लॉ, एक्शन एंड रिएक्शन. ये इस पे लगा रहा है तो ये भी इस पे लगाएगा, सीधी सी बात है. एक्शन एंड रिएक्शन कम्स ऑलवेज कम्स इन पेयर. ये इस पे लगाया तो ये भी इस पे लगाया, तो फोर्स ऑन फर्स्ट ड्यू टू सेकेंड, फोर्स ऑन सेकेंड ड्यू टू फर्स्ट, एंड डिस्टेंस बिटवीन देम इज r. अब बात है डायरेक्शन जो होता है वेक्टर क्वांटिटी का, इट इज ऑलवेज टेकन फ्रॉम फाइनल टू इनिशियल. डायरेक्शन वेक्टर क्वांटिटी का कभी ईस्ट वेस्ट नॉर्थ साउथ से नहीं लिया जाता, इट इज ऑलवेज टेकन फ्रॉम फाइनल पॉइंट टू इनिशियल पॉइंट. तो अगर ये डिस्टेंस हम मेजर करते हैं Q1 और Q2 का, तो इस डायरेक्शन में देखेंगे तो इट इज R21, R12 फ्रॉम दिस डायरेक्शन इफ वी आर मेजरिंग डिस्टेंस फ्रॉम हियर टू here, and if we are measuring distance from in this direction it will become R21. okay, and as you can see दिख रहा है एकदम क्लियर दिख रहा है कि R12 is equals to R21 vector equals to vector R. तीनों का मैग्नीट्यूड बराबर होगा, डिस्टेंस नहीं चेंज होने वाला है. यहां से यहां तक का डिस्टेंस हमेशा सेम रहने वाला है. सिर्फ क्या होगा, डायरेक्शन अगर हम यहां से देख रहे हैं तो R12 हो जाएगा, अगर हम यहां से देख रहे हैं तो R21 हो जाएगा. डायरेक्शन बदल सकता है फाइनल और इनिशियल का, बट द मैग्नीट्यूड R12 इक्वल्स टू R21 इक्वल्स टू R. ये तो कांस्टेंट रहने वाला है, ये नहीं चेंज होने वाला है ना. सो एज वी ऑल नो कि फोर्स हमारे पास 1/4 पाई एप्सिलॉन नॉट Q1 Q2 upon R square. This is the force we had calculated by Coulombs law. Now this is the magnitude of force for direction. Simplest तरीका, the most simplest technique is just to multiply a unit vector in this magnitude. And now what is this unit vector? Unit vector is a vector whose magnitude equals to 1 and it has only direction. यही क्लास 11 में आप लोगों ने पढ़ा होगा कि a vector whose magnitude is 1 and it has only direction. So unit vector is given by a cap. It is equals to vector A upon mod of vector A. This is unit vector. So just multiply your unit vector. So force on 1 due to second, it will be 1/4 pi epsilon naught Q1 Q2 upon R square into unit vector R12. Okay. And force on second due to first, it will be equals to 1/4 pi epsilon naught Q1 Q2 upon R square into unit vector R21. Okay, Now you can see R12 is equal to R21, but direction में ये opposite है. That is, since R12 is equal but in direction it is opposite to R21. Therefore, जो force on first होगा due to second, it will be equal to force on second due to first, but direction will be opposite. F12 equals to F21, but negative sign shows that the direction of both the forces are opposite to each other. Okay. अब इसमें थोड़ा सा अगर हम लिख लें कि force equals to 1 2 या 2 1, both the forces are equal, only direction is opposite to each other. So vector force 1 by 4 pi epsilon naught is to q1 q2 upon r square into unit vector r. This can be written as 1 by 4 pi epsilon naught q1 q2 by r square. Unit vector r को, since unit vector r can be written as vector r upon magnitude of vector r, so it can be written as vector r upon magnitude of r. So now force vector 1 by 4 pi epsilon naught is equals to q1 q2 upon r cube into vector r. This is vector form of Coulombs law. This is known as vector form of Coulombs law. Now what you have to do is just pause the video and make the note of all the things which is on the board, which is you can see on the board. Okay, so this vector form is also a favorite topic of boards. They can ask you to show the vector form of Coulombs law, so it's important. Just the game is of, all the game is of direction. सिर्फ directions का game है vector form में. Otherwise आप Coulombs law समझ गए तो vector form is same, सिर्फ directions का game है. So just pause the video and make a note of each and everything. Okay student, now let us compare the electrostatic force and gravitational force. Both the forces are two fundamental forces in force system. Both are the fundamental forces. So what is comparison between them? So first of all we will look at the points of dissimilarity between them. दोनों में क्या difference है? Okay. So first difference is electrostatic forces, or it can be attractive, it can be repulsive. Electrostatic force can be attractive or it can be repulsive. Electrostatic force का nature दोनों हो सकता है, attraction भी, repulsion भी. Whereas gravitational force is always attractive. Two masses always attract each other. They never repel each other. Masses जो हैं, Newton's का law of gravitation आपने पढ़ा है. They always attract each other. They never repel each other. Okay. Second is it is two charge interaction force. ये इलेक्ट्रोस्टैटिक फोर्स क्या है? जब दो चार्ज आपस में इंटरेक्ट करते हैं तो उनके बीच जो फोर्स लगता है दैट इज इलेक्ट्रोस्टैटिक फोर्स. और ये क्या है? इट इज टू मास इंटरेक्शन फोर्स, जब दो मासेस आपस में इंटरेक्ट करते हैं. उसके बाद इलेक्ट्रोस्टैटिक फोर्स इज अ लार्ज फोर्स. इट इज वेरी स्ट्रॉन्ग. लार्ज मीन्स इट इज एक्चुअली स्ट्रॉन्ग फोर्स, वेरी स्ट्रॉन्ग फोर्स. And it is small. Small means it is a weak force. Gravitational force is a weak force. So these are the points of dissimilarity between the two forces. And now we will discuss. Now let us discuss the points of similarity between the two forces. Two forces means electrostatic force and gravitational force. So first point of similarity is that both the forces obeys inverse square law. Means both the forces are inversely proportional to the square of distance between them, that is proportional to 1 by r square. Second, both the forces acts along the line joining them. Acts along the line joining them means अगर gravitational force है तो यहाँ पे मास होंगे m1 और m2, तो ये जो फोर्स इनके बीच ग्रेविटेशनल लगेगा इसी लाइन पे लगेगा, जो लाइन इन लोग को द लाइन जॉइनिंग द टू मासेस. इन सेम वे इफ वी आर हैविंग टू चार्जेस q1 एंड q2, in same way इस पे भी जो फोर्स लगेगा इट विल एक्ट अलोंग द लाइन जॉइनिंग देम. ओके, Both the forces are conservative in nature. Both the forces are conservative. Conservative forces you know very well. You have studied in class 11. Both the forces obeys Newton's third law. Newton's third law is action and reaction. So both the forces obeys Newton's third law. So that's all from Coulomb's law. Now what you have to do, you have to pause the video and make a note of similarity, dissimilarity, Coulomb's law in vector form. So first point in the notes will be Coulomb's law of electrostatics. Second point will be Coulomb's law in vector form. Third point will be comparison between electrostatic force and gravitational force, similarity and dissimilarity between both the forces. So all these notes you have to make in your copy. Okay. So that's all for today. We will discuss the next topic in the next class. Till then, take care. Have a good day.